welcome to Mr. Tutor's YouTube channel.
And there you have it. You have been welcomed to this new video. Alright, this is Algebra, our second lesson. It's always good to start a class with a bit of a review of what happened last time. So, I think everyone in the room was here yesterday. So what did we do? We drew some seesaws. And I introduced this idea that a seesaw is balanced if I have the same amount of weight on both sides. For example, if I have, I'll pick a different number this time, if I have 50 kilograms on one side, and I've got another weight on the other side, I don't know what it is, I'm just going to call it X. But I also know if it's balanced. What is the value of X going to be?
50.
Yeah, it's balanced because you must have the same amount on both sides. Today, I'm going to turn this into an equation. I'm going to say 50 equals X. So I want to take this opportunity to talk about what the equals sign means. Just very briefly. I'm going to ask the class now, what do you think the equal sign means? You've used it for a long time, but what's your understanding of it?
The same.
Sam, do you think it's the same?
Like say on both sides.
The same number on both sides. Okay, that's one idea. Anyone else got a different idea? What equals means? Can you give me a nod if you agree with Sam's definition? Same number on both sides? Okay. Wow. So yes, that's exactly what the equal sign means. There are some misconceptions. Do you know what misconception means?
Yep.
What does that mean?
Like, where you believe something about it, but it's not actually what it is.
Yeah, it's like a wrong idea. Okay? So a common misconception, number one, is that the equal sign means calculates. For example, when you went through primary school, you probably did this. 2 plus 2, tell me what the answer is. And then you would have written an equal sign, and then you would have written 4. So some people think the equal sign means calculates. Now we have done a calculation here, but the real meaning of the equal sign is that it's the same number on both sides. The reason why these two numbers are equal is because 2 plus 2, whatever that is, and 4, they have the same value. Alright, think of the equal sign as a relationship. Not a relationship between two lovers, but a relationship between two numbers which have the same value. Okay, an equation can be true or false. So let me just show you a couple of examples. If I tell you that 5 times 10 equals 75, is that a true equation or a false equation?
False.
You're just playing advocate, aren't you, Ferg? Yeah, this is a false equation. Okay? What would I need to change to the right-hand side of this equation to make it true? Okay, so you want to change the number 75 to 50, and I would agree with you. Yes. Okay. This equation is now true. Generally, when you're doing maths, you only want to write down equations that are true. Equations that are true are useful to us. Okay. Alright, so remember, equal sign describes a relationship between two numbers. They have the same value. Now that we know that, it's time to start our journey into algebra and solving equations. Okay. Pick a different number to sum 40, 10, and x. Okay, I want to write down an equation to describe this situation. So remember, a seesaw is balanced if the sum of the weights on both sides is the same. An equation is true if the numbers on both sides are the same. So hopefully you're seeing why I spent some time on this seesaw analogy, because the seesaw balance is actually the equal sign. Okay, so I want to turn this diagram into an equation. Suggestions? Okay, Stuart.
You could do like 10 plus x equals 40.
What do you think? You comfortable with that? Okay. Why are we adding? Maybe that's a very simple question, but it's worth stating. Why have we chose to add rather than minus or times or divide?
Easiest way to get to 40.
Think about it this way. What's the total weight on this side?
40.
When you do total, what does that imply? When you find a total, what do you do? When you find a total, you add. Okay? That's why. Okay. I'm going to do a couple more. This time, I'm going to draw this diagram. I want to turn this into an equation. Now I've got two x's on the other side. Yes, I agree that x is 20, but let's just write down an equation to describe this situation first. Darcy?
X times 2.
Yep.
Equals
X times 2 equals 40. And a more concise way to write x times 2 is 2x. So I'll write underneath here, this means x times 2. Okay. From this point onwards, we're going to deal mainly with what's on the right, just the equation. Our goal today is if I give you an equation such as this, I've written down 4 examples of equations. So I'm going to teach you how to solve equations. Now, I think you've already done this last year, but I'm going to be very, very particular in the way that I ask you to show your working out. So at this point, please grab this sheet. It's called Solving Linear Equations. And I want you to take a look at the first page. On the left-hand side, it says single-step equations. All the equations that we're going to solve today only require you to perform one step. So have a look at the first one. You see the equation says a plus 3 equals 10. My goal is to find the value of a, which makes the equation true.
7.
It's 7. Now, I think most of you can just look at that and see that it's 7. Okay? But what I want you to do is I want you to show the step that you are performing to get to the answer. So in red writing, it's not so clear on the screen, but on the sheet, you'll see I've written in a different color there. I've minus 3 on both sides. Why do you think I've minus 3 on both sides, not just one side? Let's do it.
Well, because so that they remain equal, you have to like do the same thing for both sides.
That's right. So this is the key idea I want you to remember. I seem to be out of paper already. How did that happen? Yeah. Oh, there's more. Okay, so here's the big idea. By starting with an equation which is true, you can generate another equation which is also true by doing the same thing to both sides. Okay? So for example, you could choose to add a number to both sides, you could choose to subtract, you could choose to times, you could choose to divide. So let's take a look here. Got some examples here. In a moment I'll give you a table to make life easier. I want you to solve these equations not by just guessing the answer or looking at it. I want you to be conscious of what step you are performing to both sides. So use the sheet to help you if you wish. Let's just look at the first one, x plus 5 equals 12. My goal is to get x on its own, or x by itself on the seesaw. So what would I need to do to both sides so that I just had x? Take away 5. So notice that I'm adding, and to get rid of the adding, I have to minus. So the step you're going to perform is subtraction. So what I want you to do is I want you to get a different colored pen and write minus 5. I expect all of you to show you're working out like this. These are your training wheels for riding a bike. Try to source one if you can. It'll make life easier for you. Okay, so we've subtracted 5 from both sides in this equation. So now I'm going to write down another equation which is going to flow on from the first equation. So what will happen to the right-hand side? If I take away 5 from 12, what am I going to get?
7.
Okay. And what about on the left?
N.
Yeah, what happened to the plus 5?
F. You took it away.
Yep, we've gotten rid of it because we decided we wanted to get rid of the plus 5. That's why we took away 5. So at the end, you're just going to have x equals 7. So the difference between just writing down the answer and showing this step in red is that you've actually shown me what you've done to get the answer. And that's better than just saying, oh, I know the answer. Because a time will come, mostly in year 9 and 10, where you can't write down the answer so easily. So for example, if I gave you an equation such as this, can you tell me the answer as easily now? You'll have to do a little bit of work. Okay, so it was easy here, not so easy here. We'll start with easy ones, and I still want you to show you're working out what I've got here in red. Okay, this is about building good habits. All right, second example. This time we're going to look at x minus 12 equals 18. Again, my goal is to get x on its own. I want the value of x which makes this equation true. And the way that I'm going to do that is by doing something to both sides of the equation.
Add 12.
Add 12. Why have you chosen to add 12 this time, Darcy?
Because addition is the opposite of subtraction.
Addition is the opposite of subtraction.
Which question am I?
This one. X minus 12 equals 18.
Oh.
Yeah. Okay, so this time we're going to plus 12 to both sides. What will we get on the right-hand side?
6.
30? 6?
Oh, sorry. They,
Okay, 8 plus 2 is 10. 10 plus 10 is 20.
yeah.
20 plus 10 gives you 30. So notice, this time, instead of x plus a number, I have x minus a number. So to get rid of the minus, we chose to plus on both sides instead. Okay. So I'll get 30 on the right-hand side, and on the left, I'll just have what? X. Okay. All right. Is this coming back to you now from last year?
Yeah.
Yeah.
Okay. All right. What should we do here? 3x equals 21. Yep. Divide? Because we've multiplied x. So the opposite of multiplication is division. Okay, so this is how I want you to show your working. I didn't actually ask what number you would divide for. Why would it be helpful to divide by 3 here?
Because you're multiplying it by 3.
Yeah, so you want to get x on its own. So to get x on its own, I have to divide by the number that's currently in front of the x. And 21 divided by 3 gives me 7. If you're still uncomfortable with division, which I know having tutored the other year 8 classes is the case, if you're not sure what 21 divided by 3 is, you can read the equation backwards and say, what number times 3 equals 21? And I find that when I write it like this, you guys are able to do it much easier. Okay, last one. X divided by 5 equals 10. So you need to know that this fraction line here means division.
You multiply them by 5.
Yes, you multiply by 5 on both sides. So remember, half means 1 divided by 2. Okay. All right, and that'll give you x equals 50. Now, I think this is revision of stuff that you already did last year. Is that correct? All right. So let me explain to you why we are doing this. All right. This is a year 11 calculation. Okay. All right. I'm going to do, this is the simple interest formula. This is a formula that you will see in year 11. And I want to solve for t. I do the same thing to both sides, so I want to isolate t. Here's what I would do. Start by multiplying both sides by 100. That'll give me 100i equals PRT. Then divide by p on both sides. Almost there. Then divide by r on both sides. How many steps of algebra were there?
3.
1,
No.
2, Okay? So as you become more proficient in mathematics, your calculations will become longer. So today, our calculations only required one step. As you get through year 9 and 10, it becomes 3 steps, 4 steps. So this year, I want everyone to be able to do 2-step equations. And we'll do that next lesson. So they'll look like this. And I'll just do it because why not, right? This is why I'm asking you to clearly show your steps. It's easy when you've only got one step to do, but as soon as you've got more, you want to be able to keep track of what you are doing each time. All right? If you get your head around what we are doing for the next few weeks, it's going to be a lot smoother when you enter year 9 next year. All right, so what I would like you to do this lesson is start working through this worksheet. It's called Solving One-Step Equations. Start on this page where the title is. The ones on the back are a lot more difficult. You will quickly notice how much more difficult. I want everyone to show me that they've finished this page by the beginning of next class. All right, so before I stop the recording, are there any questions? Ferg says like, comment, and subscribe. All right, you can get started.